Welcome back, everyone. Okay, let's dive right into this. Today, we are bringing you an explainer on one of the absolutely most vital, yet honestly kind of misunderstood, pieces of infrastructure that literally powers our daily lives: the electrical power system. We're going to decode that complex relationship between the overarching electrical grid and the individual substations that make the whole thing tick. If you've ever wondered how on earth power gets from a massive generator hundreds of miles away right into the outlet in your living room, well, you're in exactly the right place. To immediately anchor our understanding here, it's incredibly helpful to think of the grid as a massive, complete highway network for electricity. It's the interstate system spanning the entire country. The substation, on the other hand, think of it like a traffic control point, an intersection, or a toll booth right on that very same highway. This analogy is going to be our North Star as we unpack all the technical details today. Here's our roadmap for this explainer. We'll hit 5 key areas: the highway of electricity, understanding the power grid inside an electrical substation, a direct grid versus substation comparison, and finally, the big picture connection. All right, part 1, the highway of electricity. Let's really solidify this foundation. As the quote goes, the grid is like a complete highway network for electricity. The substation is like a traffic control point on that highway. Just like cars need interstates to travel between cities and traffic lights to safely exit into your neighborhood, electricity needs a vast network to travel from power plants and localized control stations to safely enter your home. Keep this mental framework in the back of your mind because it'll guide absolutely everything we look at next. Moving on to part 2, understanding the power grid. Let's move to the macro level and see how this builds. At its core, the electrical grid is defined as a large interconnected network that delivers electricity from power plants directly to consumers. I really want to emphasize those words: large, interconnected network. This isn't just a single wire connecting point A to point B. It's a web of unbelievable complexity and scale spanning entire continents just to ensure that supply constantly, perfectly meets demand. The chronological journey of electricity is honestly fascinating. It's born at massive power generation stations, before jumping right onto high-voltage transmission lines. Those are our interstate highways. From there, it hits local substations to be managed and stepped down, pushed into local distribution systems, think of those as the city streets of our analogy, and finally, it arrives safely at the consumer, your home. So what is this massive grid actually doing every second of every day? It's performing a monumental balancing act. It transfers massive amounts of electricity over long distances, connecting entirely different power stations so they can work in tandem. Crucially, it maintains system stability and shares the load between regions. Like if one region is hit by a massive heat wave and everyone's air conditioners are blasting, the grid instantly pulls power from a cooler region. All of this happens behind the scenes to ensure a continuous, uninterrupted power supply. Now, on this electrical highway, the speed limits drastically change depending on where you are. The transmission grid handles immense power, ranging from 132 kilovolts all the way up to a staggering 765 kilovolts. To put that into perspective, that is enough raw power to literally jump across vast gaps in the air. But as we get closer to home, the voltage has to drop significantly. Through the subtransmission and distribution grids, the power is carefully managed until it is stepped all the way down to a safe 230 or 400 volts, which is the utilization voltage you actually use when you plug in your laptop or your phone. Okay, part 3, inside an electrical substation. Let's zoom in from the macro grid to the micro level and look at these traffic control points. A substation is an electrical installation where electricity is heavily manipulated. It's controlled, protected, distributed, and its generated voltage is either increased or decreased. So while the grid carries the power over vast distances, the substation physically alters its state, stepping the voltage way up for that long travel or stepping it down so it's perfectly safe for your neighborhood. Now, what's really interesting about this is the sheer scale of the hardware involved. Inside these fenced-in installations is a highly choreographed mechanical ballet. Massive power transformers do the heavy lifting of changing the voltage, while colossal circuit breakers and isolators stand ready to physically cut off the power in an emergency. Add in specialized current and potential transformers used for measuring flow, alongside relays and bus bars to route and protect the whole shebang, and you've got a true masterpiece of electrical engineering working silently 24/7. Beyond just stepping voltage up or down and performing switching operations to route power, substations act as our primary safety barriers. Think about protection and fault isolation.
Say a tree falls on a power line in your neighborhood. The local substation immediately detects the issue and isolates that specific fault. It effectively sacrifices a few streets of power so the rest of the massive national grid doesn't experience a cascading, catastrophic collapse. Pretty crucial stuff.
Because they are absolutely vital for control and safety, substations are peppered everywhere. As you'll see here, you'll find them right at the power plants. They sit outside large industrial factories, they stand at key junctions of the transmission systems and distribution networks, and smaller ones sit quietly tucked away in our residential areas, perfectly balancing the power flowing to our homes. Let's move to Part 4, Grid versus Substation Compared. Time for a direct head-to-head. Before we dive into the technical specs, let's just look at the sheer difference in scale. A substation's area coverage is strictly small and local. It's a single, fenced-in facility. The grid, however, it's a massive, sprawling national or regional beast. It really comes down to macro versus micro. So the crucial point is that the grid's main work is the complete journey, generating power and supplying electricity to all consumers using vast networks of transmission lines and plants. The substation's purpose, though, is highly localized. It uses specific equipment like transformers and relays to step voltage up or down, acting as a localized traffic cop to protect and distribute that energy safely within its own small area. Basically, the grid transfers power across the whole system. The substation manipulates it at a single specific point. Finally, Part 5, the big picture connection. Let's bring all these pieces together. If you take away just one concept from this explainer today, let it be this. Every substation is part of the grid, but the grid is much bigger than a single substation. It perfectly illustrates this nested, dependent relationship. The overarching grid simply cannot function without its traffic control points, and a substation has absolutely no purpose without the highway of electricity flowing right through it. So, the next time you flip a light switch in your home, will you picture the vast national electrical highway buzzing overhead? Or will you think of the silent local control points, the substations, safely stepping that voltage down and making your modern life possible? It's an absolutely incredible piece of invisible infrastructure. Thanks for focusing in with us today, and we'll catch you on the next explainer.